Okay, today we're going to learn about Pythagorean triples and corollaries. We're going to start with the Pythagorean triples first. You have, these are right triangles and these set sides. So we have 3, 4, 5. Those are set. 5, 12, 13. 6, 8, 10, which is actually a multiple of the 3, 4, 5. It's multiplied by 2. You have 7, 24, 25. 8, 15, 17, and 9, 40, 41. You have seen all of these before on your worksheets. These worksheets have all of these Pythagorean triples in them at some point in time, whether you were trying to determine if it was a triangle or if it was right, obtuse, or acute, or you were finding a missing side, but we've used all of these before. These are nice to know because you can identify them as a right triangle. So if you're missing a side of a right triangle and you're given sides 3 and 4, then you automatically know the third side is 5. These are also used on STAR test, PSAT, SAT, ACT, compass tests, all of those standardized tests that you have to take. Okay, the next thing we're going to learn about are the Pythagorean corollaries. And the Pythagorean corollaries are related to the Pythagorean theorem, which we've learned earlier. So we already know that a squared plus b squared equals c squared means we have a right triangle. But we can also use a squared plus b squared equals c squared to see if we have an acute or an obtuse triangle as well. So if we have a squared plus b squared is less than c squared, then we have an acute triangle. And if we have a squared plus b squared is greater than c squared, well, then we know we have an obtuse triangle. So let's do some examples. So my first one here, I have 9, 20, and 14. The only thing you need to be careful with is you need to make sure that c is labeled the longest side. It has to be the longest side because that's going to be our hypotenuse or our c side. So C is labeled the longest side. Okay, so that means when I come back to number 1 here, I have 9, 20, and 14. That means I need to label 20 my C side, and 9 is going to be labeled A, and 14 is going to be labeled B. And now I'm going to do A squared plus B squared equals C squared. So that's going to give me 9 squared plus 14 squared, and I'm going to compare it. So I don't know if it's less than, equal to, or greater than yet, but it's going to be compared to 20 squared. Okay, now I square them. So 9 squared is 81, 14 squared is 196, and again, I'm still not sure which one of these I'm going to choose, and that's going to be 400. And then I get 277, and now I can compare it. That is less than 400. And since it's less than, that means it's going to be an acute triangle. So number 1 is acute. Okay, I'm going to slide it over to number 2. Okay, number 2, I have 15, 8, and 17. Wait a minute, those look a little familiar. Let me come back here. Oh yeah, look, there's 8, 15, 17. That's one of my Pythagorean triples. Well, that means that I know what kind of triangle it is already. I know because it's a triple that it is a right triangle. Remember, they come in handy. So if you recognize that as a triple, then you'll know that that is a right triangle. However, if you didn't pick that up, I would label my longest side C, so that's going to be 17. And that means 15 is A and 8 is B. So that gives me 15 squared plus 8 squared equals 17 squared. That gives me 225 when I square it and 64 when I square it. Oh, and again, I see I put my equal sign here, but I'm not sure if it's less than or greater than yet either. And that's 289. And I get 289, and now I can make that determination. It is equal to 289. And like we stated before, if it's equal to, it's a right triangle. Okay, I'm going to move it on over to number 3. I have 12, 10, and 8, and it doesn't look familiar as one of my triples. So I'm going to label my longest side C, which means 10 is A, 8 is B. And I'm going to put it in my Pythagorean theorem. So it's going to be 10 squared plus 8 squared, and that's either going to be less than, equal to, or greater than 12 squared. I get 100 when I square it, 64 when I square it, and 144 when I square it. I'm going to add these together. I get 164, and that's greater than 144. Since that's greater than 144, I know I have an obtuse triangle. So, to recap, we have our Pythagorean corollaries that tell us that using a squared plus b squared equals c squared, we can actually tell whether or not the triangles are acute, right, or obtuse. If it's less than c squared, then we have an acute triangle. If it's equal to c squared, then we have a right triangle. And if it's greater than c squared, then we have an obtuse triangle. We also learned about Pythagorean triples. These are definite right triangles using these sides and any of the multiples. I can change 5, 12, 13 into 10, 24, 26 by multiplying it by 2, and that would still be a right triangle. So these are the ones that are most commonly used: 3, 4, 5, 5, 12, 13, 6, 8, 10, 7, 24, 25, 8, 15, 17, and 9, 40, 41. And those are our Pythagorean triples. They are definitely side links to a right triangle.